Hello students, welcome to the first chapter of college algebra. In this chapter we'll be exploring function. We'll look at the domain and range of function, and we'll check whether the function is increasing or decreasing on the given interval. These are the key concepts that we'll explore in the chapter. We'll look at the definition of function. Using the definition, we are going to learn how to identify whether the given relation is a function or not from table, graph, or equation of the function given. Third one, we are going to find the domain and range of algebraic function. Next, we are going to check whether the function is even function or odd function. Also, we are going to look at the definition of increasing and decreasing function, and we are going to check where the function is increasing and decreasing when its graph is given. And the last thing we'll do is, using the graph, we are going to find the maximum and minimum value of the function over the given interval. Okay, here comes the definition of function. Function, when we define mathematically, it's a rule, or you can say correspondence, that assign each element of one set, which is called the domain. Like here, this is your first set. Okay, element of this set is assigned to exactly one element of second set. You have to be very careful here. Each element of first set is associated with exactly one element of the second set. So from the first set, 2 is associated with 3 only, 5 is associated with 4 only, -1 is associated with 1 only, and 7 is associated with 14 only. That means this is function. Yes, it is a function. Similarly, if you look at this table, -4 has only one value, 5, -1 has 7, 0 has only one value, 1 has only one value, 3 has only one value, 7 has only one value, 12 has only one value. So that means this table represents a function. Similarly, if you look at this graph here, suppose if you take this 2 has only one value. When x equal to 2, you have a single y value. When x equal to 4 here, there's only one y value. So this is also a function. When you check point by point, you'll see that for every x value, it has only one y value. In the first one, the function is given in the form of mapping diagram. This is called the mapping diagram. Second, the function is given in the form of table. Third, function is given in the form of graph. Now here it's given as the set of ordered pair. Set of ordered pair. We'll check the same thing. You can see that for 1, the image is 3. For 4, the image is 4. For 3, it's 5. For 4, it's 3. There is no repetition in x value. So this is how we can write function. So yes, it is a function. Similarly, 10 minus 3x squared. For every x value, you will get a unique y value. Okay, for unique x, you get unique y, or you can say for different x values, you'll get unique y value. So this is also a function. So as it is mentioned here, we can represent function by the set of ordered pair, like this one, in the form of a table, like this one, in the form of a graph, like this one, in the form of an equation, like this one, mapping diagram, like this one, and sometimes using some verbal equation also. Okay, now we are going to look at the example. In first example here, in number 1, we are asked to find which of the following set of ordered pair defines a function. So if you look at the first one carefully, you can see that the x values are not repeating. You have 1 comma 3, negative 2 comma 4, 3 comma 5, and 4 comma 3. Meaning of that is different x values has different y value. So this is the function. First one is a function. Now look at the second one. You'll see that here we have 3 comma 4, the first order pair, and last is 3 comma 6. That means 3 has two different y values. So this is not a function, because for the relation to be a function, every x value must have a unique y value. Now, in second problem, they have given a table and we're asked to check this is a function or not. You can see that negative 1 has only one value, 0 has only one value, 1 has only one value, 2 has only one value, 3 has only one value. So this is a function. Now, in 3, we have two equations. The first one is x squared plus y squared equal to 4. If you try to sketch the graph of this using any software that you want, your graph will look like that. Now, if you take any x value of your choice, say for example x equal to this one here, then it has one y value over here, and if you go down, you'll have another y value over there. That means for every x value over here, or for that particular x value here, you have two y values. So the first one is not a function. Similarly, if you look at the second equation here, b, you have x squared plus 2y equal to 9. If you simplify this, you get y equal to negative half x squared plus 9 over 2. And if you try to sketch the graph of this function, the graph of the function is a downward facing parabola. It's a downward facing parabola, like that. And now you can see that for every x value you choose, whatever x value you want, say for example this x value here, it has just one y value. That means yes, this is a function.